All right, title a new page in your spiral notebook, the rational root theorem. Before we get there, okay, we're going to start with part one, which is to find the remaining roots of a polynomial using synthetic division. So this is what we did first today in class. And really what it's doing is it's going to bring in the relevance of why we would need the rational root theorem. So that's why we started with this in class. All right, so go ahead. If you need to hit pause, but let's start with part one with how to find the remaining roots using synthetic division. So let's start with number one. Let's suppose I give you this polynomial y equals x cubed minus 3x squared minus 10x plus 24. Now what I'm going to do is I'm going to give you a root. And so this right here is basically like a hint that I'm giving you. This is a given root. So if I give you x equals 2, can we then use that to find the remaining two roots? Since this is a cubic polynomial, we know there's 3 total. So the first thing we're going to do is we're going to set up synthetic division. We're going to take that given root and we're going to divide. So remember, when we do synthetic division, we're going to start with the x cubed term. We're going to put the coefficient. We've got the x squared term, the x term, and the constant. Okay, so let's go ahead and fill this in. The coefficient of x cubed is 1. This coefficient's -3. This coefficient's -10, and the constant is 24. Now in this box right here, we always put what x equals. So let's put x equals 2 since that's our given root. Leave a little bit of a space right here, and we're gonna then bring down the leading coefficient. Now I'm gonna pause real quick, okay, because what I want you to see here, sorry about that. So what I want you to see is that all of this in black, this is just the setup, okay? I have not done any math yet. This is just how you set up synthetic division. Now I'm going to switch over colors to blue. Now let's start doing the math. We take this number 1 and times it by the number in the box, and we get 2. And then you always add down, okay? And -3 plus 2 is -1. And we just repeat this over and over and over. Take -1 times 2, and then we add down and get -12. -12 times 2 is -24, and you add down and get 0. So one thing we talked about in class is whenever you take a polynomial and divide it by a root, you will always get a remainder of 0. So that tells me that we're doing this correctly. Now we need to put our variables back in. And if you started with x cubed and you divided, now the polynomial is reduced down to x squared. This is the x term, this is the constant, and this right here is the remainder. So if we put our variables back in, the resulting polynomial is x squared minus x minus 12. And this is now what we're going to solve to get the remaining roots. So remember, to solve a quadratic, we can solve using factoring, okay, which is a good technique, right? It's probably going to be the quickest one. We can solve using square roots, right, when you don't have a middle b term. So if you had something like x squared minus 6 equals 0, we could always add over the 6 and square root both sides, right? So that's what it looks like to use square roots. Or we could use the quadratic formula. And those are going to be primarily our 3 solving methods. And so let me just kind of like summarize this. We've got factoring, we've got square roots, and we have the quadratic formula. And when we get to a quadratic formula, I'll write that down. This is a good factoring problem, okay? So it's always worth giving factoring a try just because it's going to be the quickest. So if I split the x squared into x and x, maybe we take the 12 right here and we split it into 4 and 3. And what we see is that if we make this inner 4x and the outer 3x, it'll make a -1 if we make this -4 plus 3, okay? And so, you know, just use your factoring skills and we factor this. Now, the point is to give the roots. So let's make sure that we set the factors equal to 0, x plus 3 equals 0. And what we're going to get is x equals 4 and x equals -3 as the remaining roots. So there are 3 roots total. One of them was given to you. These are the 2 remaining roots you just found using synthetic division. Okay, let's do another example of this. Again, just kind of like this was, you know, like I said, this was one of the first skills that we learned, and plus this is in preparation for learning the rational root theorem. Let's suppose that we have let's say f of x equals x cubed plus 2x squared plus 9x plus 18. And this time, the given root is going to be x equals -2. All right? Well, I would even like to see maybe that you try to take it from here, hit the pause key, see if we can set up synthetic division, and then when you're ready, you can hit play and we can, kind of go through this together, because in class, the students did this on whiteboards. All right, let's set up synthetic division. The highest degree is x to the third, so we're going to start with 1 for the coefficient, 2 for the x squared term, 9 for the x term, and 18 for the constant. And in the box, we always put what x equals, and x equals -2. So let's run through. Let's bring down the leading coefficient right here, and we're going to multiply and take 1 times -2 is -2, and we always add, and this time we get 0. 0 times -2 is 0. We add down to get 9. 9 times -2 is -18. So one thing I really like about this is because we get that remainder of 0, this makes me feel confident that we're on the right track so far. Okay, let's put our variables back in. If we start with x cubed and we divide, this is now the x squared term, this is the x term, this is the constant, and this is our remainder. And so the resulting polynomial that we're solving is x squared plus 9 is equal to 0. Let's come back up here to our solving methods. This is a good square roots problem because we don't have a middle term. Okay, it will not factor more, but that's okay, because what we can do is we can minus the 9 to the other side, and we can then square root both sides and get the remaining roots. Okay, so if we square root both sides, we're going to get x equals, don't forget your plus or minus. Now the square root of -9 is going to split into this, okay? Well, we've got the square root of -1, which is imaginary, and we also have the square root of 9. So the square root of -1 is going to be the I part. The square root of 9 is going to be a whole number 3. So the remaining roots are plus or minus 3i, okay? And those are going to be the 2 remaining roots. And between those 2 that you found and the root that was given, that makes 3 total. All right, so we need to run through one more problem. Okay, maybe this time, like I said, you can even pause the video and try this on your own, because like I said, students did this on whiteboards in class. So let's go x cubed plus, I'm sorry about that. Let's go x cubed plus 4x squared minus 2x minus 20. And this time, again, I'm being a little bit redundant with the roots, but this time, again, our root is going to be x equals 2, okay? That's just kind of a fluke that I keep giving you 2's and -2's. The root really could be any kind of like whole number or fraction. So hit pause, run through synthetic division, see if you get a remainder of 0, okay? All right, I'm just running through the synthetic division, and in the box right here, we're going to put x equals 2, see if this works. All right, 1 times 2 is 2. I add to get 6. 6 times 2 is 12. Add to get 10. 10 times 2 is 20. So yes, we get a remainder of 0. Let's go put our variables back in, and the resulting polynomial is x squared plus 6x plus 10. And now we need to solve this. Okay? Well, I think you can kind of tell that you're not going to be able to factor this. We're not going to be able to split the 10 to make a 6. So what our third method is that we're going to need to do is the quadratic formula. So maybe go back up towards the top of your notes and let's write down this quadratic formula so that we have this as a reference for ourselves. And to solve the quadratic formula, use the coefficients. You take the opposite of the middle term, opposite of b, plus or minus the big square root of b squared minus 4ac all over 2a. Okay? So let's go ahead and let's use the quadratic formula. The a value is 1. The b value is going to be 6, and the c value is 10. So we would say x equals the opposite of b, so -6 plus or minus the big square root. Now for the b squared, instead of writing 6 squared, let's just go ahead and put 36. All right? Minus 4 times the a value, which is 1, times the c value, which is 10. all divided by 2 times the a value. So the very first time I use the quadratic formula, I just plug everything in. I don't really do any simplifying. The next step of the quadratic formula, I leave the -6 plus or minus, and I leave the divide by 2. So in this next step, all I want you to do is get your calculator, and I want you to type in this part underneath the radical. Don't take the square root of it. The only thing I want you to do in your calculator is do 36 minus 4 times 1 times 10. That part is what's called the discriminant, okay? And when you do that, I believe you're going to end up getting 36 minus 40. So we're going to get a -4 underneath the radical. So the last piece of the quadratic formula is just to simplify the radical. Leave the -6 plus or minus. This square root of -4 is going to simplify. We have a square root of -1 and we have a square root of 4. So the negative part is going to be the I, but the square root of 4 is going to simplify to 2, and then the I because of the negative. And then we divide by 2. So the very last part is now we need to take -6 divided by 2 and 2i divided by 2, and it kind of looks like it makes a heart right there. So I kind of think of it as a heart because we need to divide both pieces, right? Give them both love. So final answer, x equals -6 divided by 2 is -3, plus or minus 2i divided by 2 is going to make 1i. And these are the remaining roots. So that first part of the video, okay, was to fill you in on what we did in the beginning of class, which was how do we use synthetic division to get the remaining roots. All right, so now on to part 2, which is the rational root theorem. Basically, how do we get that hint? Where did that hint come from? How do I get that first number that goes into the box? And what this comes down to is what's called the rational root theorem. All right, and we're just going to kind of write this out. Well, you know what? There's probably no point. I'm being kind of redundant. Let's just go ahead and kind of write what this theorem is. Here's what this theorem says. If f of x is a polynomial with integer coefficients. So what that means is that all the coefficients are going to be positive or negative whole numbers. Okay? Then the possible rational roots. So we're talking about all the possible roots that can be written as positive or negative whole numbers or fractions, okay, can be expressed as. The possible rational roots are, and what we do is we express it as a ratio as plus or minus P over Q. Okay, so what does this P over Q stand for? So basically we can express all the rational roots as fractions. So how do we define what this P over Q is? The P is equal to plus or minus factors of the constant term. So if we take the constant of a polynomial, that last number that does not have any variable, and we write out all of its factors, and on the bottom of the fraction, we list out plus or minus factors of the leading coefficient. What that's going to do is it's going to give us all the different combinations of the whole numbers and fractions that could be that first possible hint so that we could put that in the box and we could divide by it. Okay, so let's go ahead and look at an example of how this is going to work. All right, we're almost done here with the notes. Let's just kind of wrap this up with our example. So we're going to, given this polynomial f of x equals 3x cubed minus x squared minus 24x plus 8, we are going to list the possible rational roots. And the reason that we keep saying this word rational is because when we go to do synthetic division, we don't want to divide by a radical. We don't want to divide by an imaginary. We want to divide by nice whole numbers, positive or negative, and then we can also divide by fractions like 1/2, 2/3, stuff like that. But we don't want to have to divide by square root of 5 or 3i, so we're going to try to stick to the rational. All right, so when we do this, we are going to list out plus or minus factors of the constant term. So what's the constant term? The constant term right here is 8. So we're going to list out plus or minus factors of 8 divided by plus or minus factors of the leading coefficient, which is 3. So let's go ahead and list out the factors of 8. What things multiply to make 8? Well, 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. Okay, so those are all your factors of 8. Well, then in the denominator, we put plus or minus factors of the leading coefficient. Well, really, the only thing that goes into 3 is 1 and 3. So here is the list. Okay, this was just kind of your work. So what I'm going to do first is we're going to take every numerator and we're going to take every numerator divided by 1. I'm going to get rid of all that clutter right there. Okay, so we're going to take 1 divided by 1, and that's going to give us plus or minus 1 as a possibility. Okay, and then, let's see how we'll do this. Sorry about that. And then we can take, okay, sorry about that. We can take plus or minus 1. And then we can take 2 divided by 1, and we get plus or minus 2. And then we can take 4 divided by 1, which gives us plus or minus 4, and 8 divided by 1. So those are all of your possible whole numbers that could be a root. Then we take all of the numerators and we divide by 3. Okay, so the first possible is going to be plus or minus 1 divided by 3. The next possible is going to be 2 divided by 3. Okay, and so we could get plus or minus 2/3. The next possible is going to be plus or minus 4 divided by 3. And the last possible is plus or minus 8 divided by 3. So now we've got a list, okay, of all of the things that we could put in that box for synthetic division. Back in the old days, what they would do is they would try each of these kind of one by one, and they would figure out which one could be a possible rational root. However, it is 2021, and we've got calculators. So what I did is I put in my calculator, I put example 1, and when I look at the graph, okay, I look at this, and the first thing I see is it kind of looks like it's passing through at 3. Well, again, let's look at our list. Is 3 even possible? And the answer is no. And so now I know by looking at my calculator, I know that 3 is not even a possible root. I look over here, it kind of looks like -3, but I think I can tell that it's not going through -3. So right here, looking at your list, if you had to take a guess, what do you think that that possible root is? Well, I know it can't be a half because that's not possible. But when I look at this, I think a really good guess would be that that could be 1/3. And so that's how we're going to use this. We're going to make a list. We're going to look at our calculator and use the two things together to be able to get basically our first hint or our first root. And that's where we're at so far, is just being able to kind of figure out first what a possible root could be so that we could then use synthetic division to find the remaining roots. Okay, so that was just a little video on what you missed in class. We're certainly going to take this concept and practice it more. And as always, let me know if you have any questions.